Hey everyone, and welcome to our next video on this mini series on machine learning and artificial intelligence here. So in this particular session today, we're going to take a look at the future of machine learning, which is going to be something called transfer learning. Now, to many of us, this may be something new. To many of us, this may be a new topic, a new domain. We're going to take a bird's eye view on this. We're going to take a quick look at this and we'll try to understand what exactly it is, how exactly does it work, why is it called the future of machine learning, is it easy to implement? If it is, how do I do this? So these are the questions we're going to try to answer and learn this. So especially in companies which do require machine learning as a part of their job description, they would pretty much ask you about these things as a part of interview questions as well. So let's take a look at this and try to understand what exactly is transfer learning. But before we do that, we need to answer a few questions. Now, simultaneously, I also want to state that if you have any questions, any queries throughout, please feel free to ask. I'm here to answer the same. You can post any question you may have in the live chat. I will ensure to go through the same and answer any question that you may have. Now, let's take a look at this. What if I don't have enough data? Can I still perform machine learning? Because your machine learning model only learns from the data you provide. What if there's not enough data? Can your machine learning model still perform? Our simple answer is no. If I give only 3 images of cats and 3 images of dogs, and I ask the machine learning model to predict the next 100 images, it's pretty clear that it's gonna go wrong in many cases. Absolutely right. If I have only 20 sentences, 10 of which are positive, 10 of which are negative, and I ask my machine learning model to predict the next 1,000 sentences, obviously it may go wrong because these 20 sentences may have a small set of vocabulary, may have a very small set of vocabulary, where these 1,000 sentences may have words that are never there in the training set. If you try to test a machine learning model with a word like good, which is never there in the training set, it will never understand whether it's a positive or a negative word. Our machine learning model will of course go back. So is there a way to improve this? Is there a shortcut method where I can create machine learning models where there's not enough training data? There are real world scenarios like this. Think of, let's say, for example, COVID data. The moment COVID pandemic began, the data that was there was very less to analyze. So if the data is very less to analyze, how can a machine learning model predict? Think of similarly, a new company comes into stock market. The data available is very less. A new company came into stock market 10 days ago. If the data is very less, how can it predict next day's data? It will be very wrong. So there are solutions for this. Again, think of one more scenario. You want to predict whether a sentence is positive or negative in, let's say, hotel reviews, or in, let's say, something like mobile phone reviews. Now, we cannot do that unless we have enough data to train. So if we don't have data to train, of course, our typical machine learning models won't work well. There is a solution for that. So the question is, if I don't have enough data, can I still create a good deep learning model? The answer to this question is yes, we can do that. We literally can create a good deep learning model even without a lot of training data. You may wonder, you may ask a question, sir, how is it possible? If I give my machine learning model only 20 sentences, which consists of words like good and bad and so on, and if I test it with one more sentence, which includes a word like amazing, of course, I can understand it because I have learned it, but my machine learning doesn't know the word amazing because in the 20 sentences it has used to learn, it has never learned the word amazing. If it hasn't learned the word amazing, how can it predict? You're absolutely wrong, sir. It cannot. That's what we would assume. Absolutely right. This is where transfer learning comes in. The example I just took is the example of sentiment analysis, where you're trying to take a sentence and analyzing its sentiment. That is, whether it is positive or negative. That's what we are trying to do. So in this scenario, if you don't have the positive and negative words in your training set, when testing happens, if your machine learning model has never gone through a word, it thinks that the word is useless. If machine learning model as specified only knows the words good and bad, but a new word like scintillating or amazing or fantastic or whatever it could be comes up in testing data, since it has never heard that word, since it has never learned that word, it doesn't know whether that word belongs to positive or negative category. It thinks that the word has no sentiment at all. It thinks that it's a neutral word. To avoid all of this, again, one more scenario. Think of images for medical diagnosis. The moment COVID came, a lot of people did not have COVID initially. Then, in that case, if somebody wanted to find out if someone has COVID or not, just by their chest x-rays, it would have been very difficult because there's not much data to train on. There may be somewhere around 10 to 100 x-ray images only in one hospital. So if they want to create a deep learning algorithm which can take an X-ray and automatically figure out whether a person has or had COVID or not, or doesn't have COVID or not, then these amount of images are obviously not enough to create a machine learning model. This is where we begin the concept of transfer learning. As the name suggests, transfer learning refers to such situation where a model is already learned in one setting. That is, a model has already learned in some one particular domain. It has learned in one domain, but it is used in another domain. That's exactly what it means. I'll just state this. A model has learned in one domain. In one domain, there may be more than enough data. Like, for example, there may be a lot of cloud images. By taking thousands and thousands of cloud images, your machine learning model has learned how to identify, let's say, edges and features like that, how to identify edges and everything. This machine learning model, which can identify clouds, is then taken and the machine learning model is transformed. You are taking a cloud identification machine learning model and you are using it for another machine learning model to find out based on an X-ray whether something like COVID is there or not. How does this help? How does just cloud and X-ray help? I'll explain that in just a few minutes. But this is the basic idea of transfer learning. It takes an already existing model in some domain which can be used for a new domain with very less amount of data, with very less amount of time as well. That's the advantage. So there are two ways. If you want to create transfer learning by yourself, again, this is the new thing that's there in machine learning. Since last 2.5 years, this is what has been used in machine learning more than anything else. So if you want to perform transfer learning, there are two ways to do it. You can create your own model or you can create a pre-trained model. I'll explain the differences between them very, very clearly. Now think of this. To understand this better, I'll take one example. Let's assume we have a machine learning model which is already trained on images like this to identify number. Since you have a machine learning model already to identify numbers, it can identify edges. It can easily identify different kind of edges. What I need is a machine learning model to identify these kind of things. License plates. Of course, these are images. They won't help. We know they won't help. These are images of numbers. They won't help for, let's say here where there are only text, that is letters. But that's where we are wrong. A convolution neural network, remember, it identifies edges initially, right? So if you can take the first part of this machine learning model, let's say there's a machine learning model identifying images. There are 10,000 or 1 lakh images already existing, and the machine learning model is already created, which can identify edges of the numbers. If you take that machine learning model and transfer it to this, it can still identify edges. Since it can already identify edges, with less amount of data itself, it can easily differentiate between the background and edges much clearly because it already has the experience from the previous data. This is a simple example of transfer learning. So in short, we are taking a machine learning model trained on numbers, and then we are converting it and utilizing it for machine learning model to identify characters in a license plate. So it's something very easy to do because you don't need so much data here to teach the machine learning model to identify edges. You don't need so much data. You've already taught it with the previous model. It already knows how to identify edges based on difference in colors. Since it already knows that, all you have to do is just give this input. It will automatically identify edges. Then let it compare with output. Let it see if it is correct. If it's not correct, let it update its weights. That's all we need to do. This is what we call as transfer learning. So there are two ways to do it. One way is, let's assume we don't have such a previous data. We don't have a model which is already learned like this based on, let's say, digits. If you don't have such a model already existing, you need to first create a model with huge amount of data. Let's say you're trying to predict the license plate number or license plate text or license plate license numbers, whatever it could be. Since you don't have a similar model, since you don't have a related modeling problem, you have to find images of numbers or images of letters or anything like that, similar modeling problem, and you have to train a model on that. You have to build a model on those images which already exist, like letters or numbers and so on. After you train a model on that, you take first half, you take some parts of the model, that is the first few parts where it can identify edges, where it can identify features, where it can identify differences in colors and so on. After that, the rest of the model, you put it with your data. You adapt the remaining model to your data. This is exactly what transfer learning is. I hope this example has been very easy to understand. You guys can just let me know by one text in the chat window if you're able to understand this example very easily, or if you find it a little difficult, whatever it could be, feel free to let me know. I will, if there are any confusions with questions, I'll ensure to help you out. I'll give you more examples over time, not to worry. So take one more scenario. This is to develop your own model. Apart from this, there's one more way called pre-trained model. This is what most deep learning experts use. This is what most of the people use. The way it works is, think of this. If you want to identify license plates, you already have a model to identify images, that is of letters or let's say numbers. You already have a model to identify this. Since you may already have a model to identify letters and numbers, you directly take that model. In the previous case, when you're developing your own model, you don't have an already existing model for letters or numbers. So you need to create it by yourself. Whereas when you talk about pre-trained model, such models already exist. They already exist and you can use them directly. So all you need to do is take that model, just change the last few models. Let the first few layers be same as it is, which can identify edges or features or layers or all these things. Last few layers, change that so it can identify the output as these letters and change its weight instead of identifying these numbers with edges. So what it may do is, I'm just giving you an example. It may look at this 5. Your pre-trained model will understand this as 5. But since you're converting it into a different model, your different model requires this to be identified as S. It should not be identified as 5. Since it should be identified as S, when it compares with output, it realizes output is S now. Because we have changed the last few layers. Please remember, we have changed the last few layers. to ensure that the output is different, but the first few layers are same. So it thinks that the output is wrong. It predicted 5, but the output is S. So it updates saying that if something like this comes, output is S. It updates its filters accordingly. So once it updates its neurons, now it is easier for it to predict. It doesn't have to start learning what is this edge, how to identify edges. It doesn't have to do so much work. So its calculation is also faster, time taken is also lesser, your training data required is also lesser. This is the advantage of this. So let us take a look. What I want to show you is how exactly transfer learning works with image data and how exactly it works with text data. I'm going to give you an example of both with practical exposure, with practical examples, so you can understand it much better. So I'm just going to open my browser. I have a few things here already stored which I would like to show you to get a really better understanding. Take a look at this. This is called Model Zoo. As the name suggests, it's a zoo of models. It consists of a lot of pre-built models which you can directly use. There are a lot of pre-built models. I'll give you one example. There's a pre-built model on, let's say, I'll show you a few things here. There's so many models. There's a pre-built model on identifying some age and gender of people, their images to identify age and gender. There's something on car model classification. There's something here called Google Net cars, which can be used to identify car models. So we don't have any images in this web page. If you'd like, you can go through its official web pages and so on and see how exactly it works. You can try going through these websites and see how exactly it works. You can see here, this is your car model data. It's already existing. I have one question. Can it be applied into train videos? Yes, it can definitely be applied. Videos are just a combination of images. So as we know, videos are just images with multiple frames. So if you have some video, as at the question that I've received, think of this. Let's say your video is 24 frames per second. So each second will be converted into 24 different images. So these images move so fast within a second that it makes you feel like it's a video instead of a set of images. So you can take that video, put it in machine learning model using something like OpenCV and so on, where it can convert it into individual frames. You can, instead of taking all 24 frames, you can take only 2 or 3 frames with some gap, because there may not be so much quick movement in a video. So taking each frame, you can keep finding out whether an object is moving and so on. All these things can be identified. Absolutely, yes. So this is the car data set that we have. There are lakhs and lakhs of images. So if you take this data set, you train your model with this data set, your model will be able to understand edges of a car. Since your model is able to understand edges and everything of a car, it can be used to identify vehicles or buildings or anything else also. Because it's able to identify edges, you can use it for different domain also. That's the advantage. You can use it for a different domain like houses as well, and it will work. So this is just one example I'm giving. So if you want, there are thousands and thousands of such already existing models like face recognition and so many things you can figure out. So these models can be used, and all you have to do is just update the output layer to indicate that your output is something different. So that's just one example I wanted to give. So I also want to make sure that I'll show you with the practical scenario. Take this case. Everybody knows Udacity. It's many of us do know it, right? So Udacity gave a car simulator for anyone to use. This car simulator application with its videos was used to create self-driving cars in the future. So a self-driving car needs to know where to drive, where not to drive, right? So it can use these car simulator softwares. It can use games where you drive a car, like for example, as they suggested, Grand Theft Auto 5, or any other games like Need for Speed, where literally cars drive where it should go, where it shouldn't go. So to identify all of these, a different domain videos itself can be used, and then similar to this real world images are also there. So it can compare this to real world image, and then a machine learning model can be developed for a self-driving car. So this is one more example I'm giving. I'm also going to take one more example which is done by Tensorflow, that is official Tensorflow account. So what they have done here is they have taken 2000 images of dogs and cats. So they have taken 1000 images of cats and 1000 images of dogs. They want to predict whether it's a dog or a cat. Right? So simple logic. 1000 images of cats, 1000 images of dogs. But 1000 images are very less. In 1000, if I take only 500 images for training, your machine learning model will not be very accurate. So what they have done is they have used something called Imagenet. They have trained the model based on something called Imagenet. Imagenet has images from thousands and thousands of different domains. Like there's an image of a dog somewhere, there's images of a bag somewhere, a flag, a weapon, a monitor, or something under the water, a train, a disco ball. All these things are there in this image. Some flowers, some mountains, some lions, some football, all these. So all these images are bike, chair, everything. All these images are taken. They have created a model based on this ImageNet. After creating a model based on ImageNet, they have changed the final layer only. Only the final layer they have changed. After changing the final layer, this is what they have done. Fine tuning. Changing the final layer is called fine tuning. There's already an existing model. In that already existing model, you're modifying some layers of it. So modifying some layers of it is called fine tuning. So all that they are doing here is taking a pre-trained model on ImageNet and they are fine tuning it, making some small changes. They're telling that in the base layer there's already 154 layers, 154 layers in the initial model. In the initial model, they are keeping 100 layers as it is. After 100, rest of the layers they are changing. When the rest of the layers are changed and they train and test it, they got an accuracy of 97%. That's a huge amount of accuracy. That's a huge amount of accuracy. That's impossible with just deep learning models. That's how we get to figure it out. I'm just taking this as one example. So this is how we get to figure it out. You can use this for videos, images, everything. So this is how you use it for images. So I hope it gives a good idea. If you want to go for your own project and you don't have enough training data, all that you need to do is just use transfer learning. Use a pre-trained model. There are thousands and thousands of pre-trained models already existing. There are thousands of pre-trained models existing from Google itself. They can be used directly for your purpose. Now, one more case is, how about text? In images, okay, we can somehow identify edges and features. How are you going to figure out based on text? There's no way. Actually, there is a way. The way to do it is by using similar words. So here's the thing. A pre-trained model in terms of text will already be trained on some sort of text, whether it is positive or negative texts, or instead of positive or negative text, something like sports news and non-sports news, or spam mail and non-spam mail, something based on some topic. A machine learning model will already be trained. Since it will already be trained, it will know what are positive and negative words. It will know what are sports and non-sports words. It will know what is spam and non-spam words. So what a machine learning model does by these words is it identifies their similarity. If you want to know how they do it, there's a particular algorithm called cosine similarity algorithm. So using cosine similarity algorithm, they identify how similar are certain words. I will show you this in practice. So there's something by Google called Wordtoit. This is officially released by Google. This Wordtoit model has, as you can see here, similar word list. So Wordtoit model has a lot of words, lot of vocabulary. What it does here is it identifies similar words by using, as I said, cosine similarity matrix or cosine distance algorithm. So if words like Spain and Belgium and Netherlands, you can see that these are similar. So which words are similar, which words are not similar, you can easily identify them. So you can easily identify whether some words are similar or not very, very clearly. That's how we get to realize this. So the closer these two numbers are, if you see here, Los Angeles is at a number 0.66, Golden Gate is at a number 0.57. These numbers are close by. That is how you can get to know it is similar. If you say Los Angeles and Chicago, they are not so close by. They are a little far away. It's the relative distance. It's the relative distance between the two texts that you figure out. Take this for instance, Spain, Belgium, countries. So they are similar in words. Catalonia is not a country, it's a place. So it's somewhat far away. So this is how you get to figure it out in short. So this I'll just show you in practice to see how well it works. So we have this model called Google News. Based on news data, already a model is trained. I will show you the 10 nearest words. For example, if I type the word good, if I click show nearest, you can see based on good, nearest words are great, bad, terrific, decent, nice, excellent, fantastic, better, solid, and lousy. 2 times out of 10 it went to opposite words. That's totally fine. But 8 times out of 10 it got it correct. So if a machine learning model has never learned the word fantastic, it has only learned the word good, it will see where fantastic is closer to. If it is closer to good, it says that since I know good is a positive word, fantastic is closer to good, I'll consider fantastic also as a positive word. This is how these models work. So your training data should not necessarily contain all the words. Without this concept, without this technique, your training data should consist of so many words, and you should specify whether those words are positive or negative, those sentences are positive or negative. With this already existing, you don't have to do that. I'll take one more example. Let's say I'll type Tokyo. Sorry, I've typed Tokyo. Okay, let's say I'll type Tokyo. The moment I type Tokyo, you get all these words which are very similar to it. India, America, London, UK, Chinese, Washington, York, USA, San, and so on. So 90% of these words are very similar to those. So you can immediately identify. Let's say I'll take amazing for instance. One more scenario. If I take amazing, you'll see immediately here. Just by having the word amazing in your machine learning model, that's enough. If your machine learning model knows that the word amazing is a positive word, and while testing you get a word like phenomenal, you don't need to train your machine learning model based on that, because already pre-trained model exists which knows that incredible, awesome, unbelievable, fantastic, phenomenal, astounding, wonderful, remarkable, marvelous, fabulous, all these words are similar to amazing. So if your machine learning model knows that amazing is a positive word, it knows that all these other words which are similar to it are also positive. They are shown like this. You can see here certain words like computer, Android, Facebook, user, Wi-Fi, privacy, Google, all these things come close together. They are shown close together in this GIF. So it's the same way this system also works. So there are many algorithms that are created. Google has come up with its own algorithm called BERT. There's another algorithm called GPT. Sorry, there are various algorithms which are used to perform transfer learning. But this is how they do it. You can easily figure this out. You can also give two words and identify whether they are similar or not. I'll just show you in practice. Let's say I'll give awesome and unbelievable. You can see that they're very similar. If I give awesome and Tokyo for example, you can see that they're not similar. That's basically how you get to figure out. So even similar to this, let's say for example, I'll give something like man refers to, let's say for example, king, whereas a woman refers to what exactly? I want to show top 5 results. So if you take a look at this, queen, monarch, princess, crown prince, prince, all these words come up. Did I have to teach the model that such words are similar? No. So these can be used in prediction as well, word prediction as well. So you can see here that these are so very well useful. You don't need to train your machine learning model with so much data. These can be used directly for this purpose. So this is a simple practical example where I can show you. If you get a pre-trained Google News model, and if you take only, let's say, only 1,000 rows of text data or 1,000 sentences, that's enough. If you take only 1,000 sentences, based on these 1,000 sentences, whatever new word comes up in testing, it will find out which word is it similar to. Based on which word it is similar to, it will automatically understand whether it's a positive word or a negative word. So this is 1,000 times better than just a simple deep learning model as well. It gives you much better performance. Words that the machine learning model has never learned, it will still give you better performance on that. And since it's already pre-trained, it can also save a lot of time. So these are the advantages of machine learning using transfer learning. And this is why I wanted to share this particular knowledge, that this is the future of machine learning, that is future of ML, future of deep learning as well. So apart from this BERT model and so on, there are many text processing parts, like apart from Google News negative 300, there's glove model, there's Wordtoit model. There are so many models which consist of these similar words. So if you're interested, you can definitely go through it. So this is where you don't need a lot of training data, yet you can create amazingly accurate models. So this is what we call a future of machine learning, future of deep learning. So I hope you had a fun time understanding what exactly is the future of deep learning. So with this, before we end the session, we also want to state out that we have a special internship course on machine learning. This particular internship course is going to train you from scratch. We're going to train you from scratch of Python to all the machine learning models that you need to know, including every single package, every single machine learning model with practical examples, with real world data, with a lot of model building exercises. So if you'd like to know more about it, if you want to create a career in machine learning, which is the most highest paid career in computer science industry right now, do go ahead and check out the link that is shared in the description of the video. You will be going to the quantmasters.in website where you can get to know what exactly this internship course is about. If you're interested, you can contact us regarding this and we'll let you know. You can register for the same. So with this, we'll end this video of the mini series. We'll catch up in the next session where we're going to take a look at more things within machine learning, things like how is statistics important, what programming languages are important, what are we supposed to work on. We're going to take a look at a few practical examples in the coming session. Until then, keep working hard and keep learning a lot. Thank you guys. Have a good time.